Imagine opening your eyes on a planet that looks almost beautiful. The sky is deep blue, bright, clean, almost familiar. Then something hits your face. Not rain, glass. You're standing on a giant blue world where the weather is so violent that tiny silicate particles, basically the same kind of material found in glass, can be blasted through the atmosphere at terrifying speed. And they don't gently fall from the sky. The winds here can reach around 5,400 miles per hour. That means the glass can be driven sideways. On Earth, the fastest winds ever measured are only a fraction of that. Here, anything caught outside would be hammered by microscopic glass moving at hypersonic speed. And the strangest part? From far away, this planet looks peaceful. Its blue color makes it seem almost ocean like, but there are no calm tropical seas waiting below. That beautiful color comes from particles in the atmosphere scattering blue light. So the thing that makes this planet look inviting is connected to the same atmosphere that makes it deadly. Now imagine seeing this world from a spacecraft. A glowing blue sphere, clouds moving below, almost like a darker version of Earth. You might want to get closer, you really shouldn't. And if you're already wondering how much worse an alien planet can get, hit like button now because this is only the first stop. And before long, we'll reach worlds where the rain isn't made of glass at all. It's made of metal. But even before we get there, this giant planet has one more problem. This planet orbits extremely close to its star, which means it is also brutally hot. So even if the glass somehow missed you, the heat wouldn't. Beautiful from a distance, unsurvivable up close. There's nowhere to hide, nowhere to wait out the storm, and no safe moment when the atmosphere simply calms down. And yet, compared with the next planet, this one almost feels merciful, because on that world, the ground itself may be an ocean of lava. Now, imagine surviving the glass storm only to land somewhere the ground itself is trying to kill you. This is 55 Cancri E, and from space, it may look less like a planet and more like a glowing coal. It orbits incredibly close to its star, so close that a full year here lasts less than 18 hours. Think about that. You could wake up on New Year's morning and celebrate another New Year before going to bed. But time is the least strange thing about this world. Temperatures on the side facing its star can climb above 2000 degrees Celsius, hot enough to melt rock. So instead of oceans filled with water, parts of this planet may be covered by vast seas of molten material. Not lava pouring from one volcano, not a river of magma, an entire landscape glowing red beneath you. If you could somehow stand above it, the horizon might look like an endless furnace. And because the planet is so close to its star, scientists think its two sides could be dramatically different. One side blasted by relentless heat, the other much cooler and darker. Between them would be a narrow region where day slowly fades into night, a permanent twilight stretching around the planet. But don't imagine that as a safe zone. Even there, the atmosphere and heat moving around the planet could create conditions nothing like anything we experience on Earth. And here's what makes 55 Cancri E even stranger. Scientists believe its surface may not stay the same. Rock can melt, vapor can rise, material can move through the atmosphere and eventually return somewhere else. On Earth, we have a water cycle. Water evaporates, forms clouds, then falls as rain. On worlds this hot, something similar could happen with rock, which means that somewhere in the universe the weather forecast might effectively be cloudy, extremely hot, chance of rocks falling from the sky, and if that sounds impossible, keep going. Because the next planet takes this idea one step further. There, scientists found evidence of a metal inside the atmosphere. During the day, the heat can vaporize it. Then, the winds carry it toward the cooler side, and when the temperature drops, the metal begins to condense. So after glass flying sideways and oceans made of lava, we are about to reach a world where it may literally rain iron. And yes, on this planet, it may actually rain iron. This is WASP 76b, a gigantic gas giant orbiting so close to its star that 1 year lasts less than 2 Earth days. The strangest thing here isn't how short the year is, it's the weather. WASP 76b is thought to be tidally locked, meaning the same side of the planet constantly faces its star. So one half lives in permanent daylight, the other exists in endless night. And on the day side, temperatures can rise to around 2400 degrees Celsius. That is hot enough to vaporize iron, not melt it, vaporize it. So imagine huge amounts of iron existing not as solid metal but as gas mixed into the atmosphere above you. Then powerful winds begin carrying that material away from the blazing day side toward the cooler night. And something strange happens along the way. The temperature falls, the iron begins to condense, tiny droplets of liquid metal start forming in the atmosphere, and then they may fall deeper into the planet. Iron rain, a storm where the clouds themselves contain vaporized metal. But there's an even stranger clue. When astronomers studied light passing through the planet's atmosphere, they detected iron strongly near one side of the planet, but much less after the air moved farther toward the cooler region. It was almost as if the iron had disappeared. One possible explanation? It had condensed and fallen out of the atmosphere. So, if you could somehow float above WASP 76b, the sky around you might contain metallic clouds being pushed across the planet by violent winds, while below them droplets of molten iron disappear into the darkness. And remember, this isn't science fiction. Astronomers can learn about atmospheres like this by studying the tiny fingerprints that different elements leave in starlight as it passes through them. That's how we can discover weather on a world hundreds of light years away without ever visiting it. But here's the truly disturbing part. WASP 76b is unbelievably hot, and it still isn't the hottest planet we've discovered. There's another world where the daytime temperature becomes so extreme that molecules can literally be torn apart, a planet hotter than some stars, and its atmosphere is slowly being ripped away into space. Welcome to KELT 9b. Welcome to KELT 9b, a planet so hot that calling it hot almost feels meaningless. Its star, KELT 9, is already far hotter than our Sun, and this planet orbits unbelievably close to it. So close that 1 year on KELT 9b lasts only about a day and a half. But you wouldn't be watching many sunrises here. On the side facing the star, temperatures can climb above 4000 degrees Celsius. That makes this planet hotter than some actual stars. Think about that. We normally imagine planets as the cooler objects orbiting giant balls of fire. Here, the planet itself reaches temperatures that some stars never do. At this heat, chemistry begins to behave very differently. Molecules that would normally survive in an atmosphere can be ripped apart by the extreme energy. Hydrogen is being heated. The upper atmosphere is expanding, and the planet is slowly losing material into space. In other words, KELT 9b is not simply orbiting its star, it is being cooked by it. Every orbit brings it around the same enormous furnace again and again and again. But believe it or not, there's another planet whose relationship with its star may be even worse, WASP 12b. This planet also circles dangerously close to its sun, but here, gravity itself has become part of the nightmare. WASP 12b is a huge gas giant, and its star is pulling on it so strongly that the planet is no longer perfectly round. It has been stretched, almost like an egg being pulled toward the star, and the process doesn't stop here. Material from the planet's atmosphere is being stripped away. The star is slowly stealing pieces of the planet. Imagine watching your own sky disappear into space while the thing responsible for it feels more and more of the horizon. WASP 12b cannot escape. Its orbit is gradually bringing it toward destruction. Eventually, the star may consume what remains. Now we've reached planets whose own stars are killing them. But at least those stars are still alive because the next worlds orbit something far stranger, something that has already died, a stellar corpse spinning in the darkness and firing beams of radiation through space. But at least those stars are still alive. The next planets orbit something that already died. Imagine looking up at your sun and knowing it once exploded. What remains is called a pulsar, the collapsed core of a dead star. It is tiny compared with the star that existed before it, but unbelievably dense, spinning incredibly fast and spending powerful beams of radiation out into space. As it rotates, those beams sweep across the darkness like the light from a cosmic lighthouse. Now, imagine a planet orbiting that. No warm yellow sun, no peaceful sunrise, just the remains of a stellar explosion sitting at the center of your solar system. And somehow, we've actually found planets in places like this. That alone creates a huge mystery. Because if the original star exploded violently enough to leave behind a pulsar, how did the planets survive? Maybe they didn't. Some could have formed later from material left behind after the explosion. Others may have been altered, thrown into new orbits, or slowly destroyed by the brutal environment around the dead star. Either way, these are not normal planetary systems. A pulsar can blast its surroundings with intense radiation and streams of energetic particles. So, any nearby planet would be orbiting one of the most hostile objects imaginable. And there's something deeply strange about the picture. The star is dead, but the planets keep moving. Year after year, they continue circling their remains, following the gravity of something that destroyed its own solar neighborhood long ago, almost like planets orbiting a grave. And some objects around pulsars move very fast. One planetary mass object described in our reference completes an orbit in less than an hour. Less than an hour! By the time you finish watching this video, a world like that could travel through a huge part of its entire year. But even here, beneath radiation from a dead star, these planets still have one thing connecting them to something in the center: gravity. Something to orbit, something defining where their solar system is. The next planet don't even have that. No living star, no dead star, no sunrise waiting on the other side of the night. They have been thrown out of their original system completely, and now they travel through the Milky Way alone. Welcome to the rogue planets. Worlds with no sun, no sunrise, no sunset, no star waiting at the center of their system. They simply move through the darkness between the stars, alone. A rogue planet is a planet that is no longer gravitationally bound to a star, and one way this can happen is surprisingly violent. Young planetary systems can be chaotic places. Planets pull on one another, orbits shift, large worlds can pass too close to smaller ones, and sometimes one planet loses the gravitational fight completely. It gets thrown out, not into another orbit, out of the entire system. From that moment on, the planet begins a journey that could continue for billions of years. Imagine Earth suddenly being thrown away from the sun. Within days, sunlight would become weaker, then weaker again. Eventually, the sun would shrink into just another bright point among the stars, and after enough time, even that would disappear into the background. There would be no morning anymore, just darkness. At first, you might assume that every rogue planet must be a completely frozen, dead world, but this is where things get strange. Some scientists have suggested that certain rogue planets could potentially hold onto thick atmospheres, and if that atmosphere trapped enough heat from inside the planet, conditions beneath it might remain much warmer than you would expect. A world with no sunlight, but perhaps still with heat. Possibly even liquid water hidden beneath ice or protected beneath a dense atmosphere. If anything lived there, it couldn't depend on sunlight the way most life on Earth does. No forests, no grass. Life would have to survive using energy from the planet itself, perhaps around warm regions deep underground or near something similar to hydrothermal vents in Earth's oceans. And finding these worlds is incredibly difficult. They don't regularly pass in front of their own stars because they don't have stars. They produce almost no visible light of their own, so astronomers sometimes have to detect them indirectly, watching for the tiny gravitational effect they create when they pass in front of distant background stars. For a brief moment, gravity bends and magnifies that distant light. Then the planet disappears back into the darkness. And the unsettling part is that we don't really know how many of these worlds are out there. There could be enormous numbers of them drifting through the Milky Way right now, invisible, silent, passing between solar systems without anyone ever noticing. But darkness doesn't always mean an empty world, because some planets may have exactly the opposite problem. Instead of having almost nothing on their surface, they may have far too much of one thing: water. Imagine falling into an ocean and swimming downward for hours, then days, and still never reaching the bottom. That's where we're going next.